This video is going to be going over curve sketching. It's got a number 1 because I'm going to be doing the first problem that we had from the review sheet. Okay, we were given a function, f of x is equal to x squared over x squared minus 9. First thing we need to do, we need to find out what's going to give us a 0, and since we have a basically it's a rational function, but it's like a fraction. So whenever the top is 0, then we're going to have a 0. So 0 squared is 0, so we know we're 0. And we need to find any discontinuities, which would happen whenever the bottom is 0. And as you can see, the bottom factors to x plus 3, x minus 3, and whenever you solve that, you have a discontinuity whenever x is plus or minus 3. And we need to find any asymptotes that we have. Since our powers are the same, we're going to have a horizontal asymptote wherever the whatever ratio that is. And so since that's basically 1x squared, 1x squared, we're going to end up having a horizontal asymptote at 1, which is the line y equals 1. Alrighty, so now that we know that, it's time to move on and start taking derivatives. So the function that we had, whenever you take the derivative of that, you can see that we're going to be using the quotient rule, which is basically the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So whenever we go through and do that, we come out to right here, and as you can see, our positive 2x cubed and our negative 2x cubed are going to cancel. So we're going to be left with a negative 18x over x squared minus 9 squared. And you do the same thing. You set top and bottom equal to 0, and whenever the top is 0, you're going to have a 0, and whenever the bottom is 0, you're going to have a discontinuity. But anyway, all of those are our critical values for our f prime. Okay, so then we need to take the second derivative, and so here's the part that we're going to be using, which was our f prime. Take the derivative of that. If you didn't want to use the quotient rule, you could do what I did right over here to the right and set it up where you can use the product rule. And basically all I did was I took the denominator and I moved it up top by changing the power of the exponent. And so that pulled us up there, and we can use the product rule instead. And so the product rule is just the first times the derivative of the second plus the second times the derivative of the first, and that's all it is. So that's pretty simple. Y'all can figure that one out. And 0 was not a critical value for that one. But so anyway, the critical values for this one came out to plus or minus 3. By substituting in, because whenever you plug in a plus 3 or a minus 3, you're going to end up getting zeros. So we're going to have our discontinuities there. So now that we need to go through and gather everything that we know and get ready to sketch our graph. Okay, so here's everything that we know. Our zeros, our discontinuities, our horizontal asymptote, and so now we need to figure out our increasing and decreasing and concavity. So whenever you plug in a number less than -3 and to your x to your f prime, you should get a positive. Pick one between -3 and 0. You should get a positive. Between 0 and 3, negative, and anything bigger than 3, you should get a negative. And then whenever you use those same numbers for the f double prime, you end up with a positive, negative, a negative, and a positive. So here we know we are increasing and we're concave up. Here we are increasing and we're concave down. Here we are decreasing and we're concave down. And here we are decreasing and we're concave up. Alright, so now that we know all that, it's time to put all that onto a graph. So here's going to be our graph. Yay! Okay, so we said at 3 we had a discontinuity. And one at -3. Okay, at 0 we had a 0. And at the line y equals 1 we had a horizontal asymptote. Okay, so if you remember back to our little number line that we did, we said less than 3, we were going to be increasing and concave up. Well, because we have our horizontal asymptote right here, we know we're going to have to be above the asymptote, because we can never touch it. So we're going to have to start out above it. So there we're increasing up. And then we were decreasing down, but we have our 0 to think about. So we're going to have to be coming up to meet it. I'm sorry, we were increasing down. I apologize. But so here we go. We're increasing, but we're concave down. Okay, so then greater than 0, we were decreasing and concave down. So we are going to be going towards our discontinuity, which is our vertical asymptote. And then for greater than 3, we are decreasing and concave up. So here we go, we're decreasing and we're concave up. So that is curve sketching.